Hello everyone and welcome to today's workshop. We will have the second day of this marine data for coastal monitoring. So this is a Copernicus Marine Service workshop, and today we will have a practical session. So yesterday, for those of you who were there, we gave you an introduction to the Copernicus Marine Service, what sort of data you can find in the service and what we provide in terms of global data. And we also provided some examples on how you can use the data for coastal issues. So today we will have a more practical session. So we will show you how you can visualize the data sets and how you can apply it to a case study. So before we start, we are going to go through house rules and guidelines to help you follow this workshop the best possible way. So first, please do not use the chat that you see on your right-hand side for your questions. You can use it for small talk or to say hello to us, but if you have a more technical question or if you have any other question, we will use the Q&A section on the website. So globally, all the Zoom features are not accessible. The chat and raise your hand, it doesn't work. So concerning the Q&A section, you can find it there, and it's on the website on the top bar of your page. And if you click, you will see an area dedicated to the Q&A, and that's where you can ask our speakers your question today. So speaking of our speakers today, so we will start with the Jupyter Notebook tutorial by Alvaro de Pascual Cola, and then Stefania Ciliberti with the QGIS presentation. And finally, Alvaro will be back for his second presentation on RStudio. Today, as I said, it's a practical session, so you might have explored already all the materials we made available for you and the specific exercises that were developed for the topic we will present to you today. As you can see on the tab on the website, you will find 3 tabs, one dedicated to the Jupyter Notebooks, one to QGIS, and another to RStudio. So I hope you had the time to explore these exercises. And I've now some questions for Stefania and Alvaro, who developed these exercises. Please do not try to do the tutorial in the meantime, same time as their presentation, because they will do just a summary of the tutorial, so you won't have time to follow everything. If you're curious, don't hesitate also to visit the e-learning pages on the website, where all the tutorials from previous workshops are available. Also, yesterday, some of you made the same comment about one of the tutorial which wasn't working. So the error has been fixed. You just need to download again the tutorial to have it running good. So sorry for this mistake. If it's still not functioning correctly, please let us know. Don't hesitate to send a comment, or we will try our best to fix this, and we'll let you know when it's good again, if it's not still the case. You will also have all the replays and the PDF presentation available in the next 7 or 10 days. We will send you an email when it's okay, so don't worry about that. And you can also find the polls next to the Q&A section, so you might have answered already yesterday. If that's not the case, or if you want to change some answer, you can. So don't hesitate to go and have a look. And we'll start with the first tutorial. So it's for Alvaro on the Jupyter Notebook. So whenever you want, the floor is yours.
Hello, welcome to everyone. Good morning, guys.
Hi.
Let me share my screen. Can you see my screen, right?
Yes, it's good. Yeah, perfect. Nice.
Fine. Well, in this tutorial, we are presenting a Jupyter Notebook programmed in Python language to propose a short study of the storm surges associated with cyclones in the Bay of Bengal. Well, as Kyle said before, there is a tag in the webpage of the course where you can access the Jupyter contents. In this Jupyter contents, you will find different buttons where you can access the contents. Here, for example, you can access the Jupyter Hub platform that we provide to users to run the notebooks. But to access to this Jupyter Hub, you will need to be registered in Copernicus Marine Services, right? So you will need to first be registered, and you will access through using your credentials, your Copernicus Marine Service credentials. There are also two more buttons where you can download a tutorial, and you will find also instructions to install this tutorial in your own computer. So you can run the tutorial in your own computer, and then you can get some functions that you will find in the tutorial. So you can use these functions and this code for your own interest. Well, it's important to say that, well, once you access the Jupyter Hub button, you will be redirected to the Jupyter Hub environment. And it's important to note that you cannot run the tutorial directly. It's mandatory to copy the tutorial in your home directory. So to copy the tutorial in your home directory, to do that, you have to push this button, a terminal that will open a Linux terminal in your system, in your hub, and you have to type this command, copy -R Jupyter Notebooks Training Coastal Monitoring 2024, and finish with a dot. Let me show you how to do this. Clicking in. Well, this is the web page of the tutorials, as I explained just before. By clicking here, you get access to the Jupyter Hub environment. And, well, this is not my case. I entered directly to the system with login. But if you access to the system, you will be asked for your Copernicus Marine Services credentials. You can access this service by using these credentials, and after that, you will get this window where you will find two main sections. You will find two main panels. In the left panel, you will find a file browser where you can see different files and folders. It depends. The files you have here depends on your work. You can have different folders, different files, but for sure you will have this Jupyter Notebooks folder in your home directory. And also you will find this region that has it's actually the workspace. So as I said before, it's very important to consider that you need to copy the tutorial into your home folder. The tutorial is in this Jupyter Notebooks folder, but you cannot run the tutorial here. You need to copy the tutorial to your folder, your home folder. So to do that, you click on Terminal and type copy -R Jupyter Notebooks Training Coastal Monitoring 2024 and a dot. And when you do that, you will realize that there appear a new folder that it's called Training Coastal Monitoring, and you can enter in this folder and run the tutorial by double-click in this EPYNYNB file. Right? I have here a tutorial already run. We can go over to the tutorial and you will see that this is a Jupyter Notebook. I'm not sure if you are familiar with this format. The Jupyter Notebooks has a mixing of documentation and cell codes that you can run and modify. For example, here in this tutorial, you will find there are 4 different sections. So we start with a very short introduction speaking about storm surges and the cyclones in the Bay of Bengal and the relation of cyclones with the storm surges, the effect of the inverse barometer, etc. And you will find this kind of cells that you can run by clicking the run button up here. So once you run the cell is run and the system contains in memory all the variables you created in every cell. Well, let's go back to the presentation. Here in this tutorial, as I said before, we are presenting a study of storm surges associated with cyclones in the Bay of Bengal. And this tutorial, first of all, in the first section, we focus in downloading the data we need for the tutorial. So we use a very interesting Python library, which is a Copernicus Marine Toolbox. It's a library developed by Copernicus Marine Services. And we will learn how to download to different data sets from Copernicus Services, Copernicus Marine Services. One of them is a data set provided by satellite or produced by satellite data, represents satellite. And also we will download also data from reanalysis, numerical modeling. And we will do the tutorial with these 2 different products, and we will see what difference we get, because they have some difference in their results. First of all, we focus in a specific cyclones. You will see that in the tutorial you can select different cyclones to analyze. In my case, I have analyzed the Giri cyclone. And first of all, we learn how to plot maps of maximum sea surface height during the cyclone, the impact of the cyclone in the region. So we get 2 maps for satellite data and reanalysis data. And here you can see some of the results we get. That is that despite of both products create a very, very similar spatial pattern, they have different values in the color scale. For example, the satellite data provides values of sea surface height of about 1.5 meters, and in the case of reanalysis, it produces values of 1 meter, barely 1 meter. So we go deeper in this result and we analyze these differences during the rest of tutorial, and we focus in a specific latitude and longitude point. In this case, we focus in this point that is one of the main regions affected by this Giri cyclone. And we plot the time series for this period, for the complete period we are analyzing, and also including the Giri cyclone. And we realize that both products produce very similar results, but with a clear bias. And this is a common result because this kind of products related with sea surface height usually must be calibrated before being used. And here we have the period of the Giri cyclone, so we can see that this cyclone produced probably one of the highest sea surface levels in this region for the whole record that goes from 2010 to 2020. After that, we create a scatter plot to compare these results. So we create a scatter plot between these both products using satellite data and reanalysis data, and we compute the regression line of these two data sets, and also we include the results of the cyclone we are analyzing, and we realize that effectively that there is a clear bias of about 0.3 meters, but the results between both products are actually really similar. Well, this is the results, a very short summary of the results we show in this tutorial. I hope you enjoy the tutorial, you find interesting information. And well, this tutorial also provides some functions that you can use for very different uses. For example, you will get functions to plot scalar maps that you can apply to very different variables like sea surface temperature or any other variable, or time series or scatter plots and computing of regression lines, etc. Well, this is the tutorial.
Thank you very much, Alvaro. So we seem to have the same question as yesterday concerning the permission when you explain how to copy the tutorial on their homepage. I don't know if you could go again over that for people to understand how it works, because I don't know if everyone was connected at the time.
Excuse me, what is the question? Permission about what?
The question is they have an issue saying to them permission denied on the tutorial, and I think it's the part where you explain to copy the tutorial on their homepage for Jupyter. So if you could explain that again, I think it would help a lot of people.
Yeah, of course, I think.
And as I said at the beginning, while you share your screen, as I said at the beginning, we had an issue on the tutorial yesterday on the cloud. We shared it to you for the participants. So you should download it again because the first version you might have downloaded earlier than 2 days ago, it's not the good one. So if you could try to download again and try again the tutorial, I think it will work this time. It should work this time.
Yeah, maybe. I'm not sure if this permission is related with, I'm sorry, this doesn't, no. Is related with this copy of the tutorial. I don't know. I should have a look, a specific look of the problem, because I don't find any problem. It's very important to have in mind that you have to copy the tutorial in your home folder, because it's possible if you find the tutorial in the Jupyter Notebooks folder, you enter in the tutorial and you try to run the tutorial inside the Jupyter Notebooks folder. This Jupyter Notebooks folder is not a folder for running tutorials. It's a folder just to store the tutorial. So you please do not try to run the tutorial inside the folder, because this doesn't work. You do not have permission to write in these folders, so you will find many errors. And maybe sometimes it's possible to find some. It's possible also to find some errors when you are running the tutorial. Maybe a good option, if you get any error during the tutorial, a good first option would be go to kernel and restart kernel. Maybe there is some kind of, you have started two tutorials at the same time, so there is some kind of, so if you get some errors during the tutorial, it could be interesting also to go to kernel, click on kernel, and click on restart kernel. You will restart the kernel, and unfortunately, you will need to restart the tutorial from zero. But well, this could also solve some issues, running issues.
Okay. Well, if someone still have trouble with this tutorial, send an email to the user support and we try to help you if it's still not working. But okay, thank you very much, Alvaro. So we have 2 questions on Slido. Thanks, Chloe. So the first one, someone is asking if you could perhaps make a slightly change to the analysis so we can see the new graph being produced. So, because you showed just a summary, I don't know if you can do this live.
Yeah, I don't. Let me check if, well, for example, to do that, I should run the full tutorial. I can go over this, for example. No. Okay. This is, I will go over this. And this. Well, I am running the tutorial really, really fast, just to go to a point where we can get, for example, here, you can see we have created, here we are
showing your screen.
I'm sorry.
No, don't worry, it's fine.
Well, here I have created, as I said before, I worked with Giri Cyclone and if the first result we create is these maps of maximum sea surface height during the period of the cyclone. But if you want to change this cyclone, you can change here in this cell. There is the variable that specify the parameter specify the working cyclone you want to use. So if you want to work with a different cyclone, you just need to comment this line and comment, for example, if you want to work with Hood cyclone. And from here, you can start running again the tutorial by running every cell. And from here, you will be plotting, for example, the results for a different cyclone. In this case, hot cyclone, and there is also a place where you can modify results. For example, here in this. Sorry, there is a bug here. Well, there is a bug here. I will have to correct this bug in this morning. Well, you can change here. Here we are in this cell. We are specifying the latitude and longitude locations we want to use for the analysis of time series. For example, here you can see that we plot the location of this location. But if you want to change the specific location of this where you want to do this analysis, you can just comment these values and say, for example, instead of 2187, you can use, for example, let's say 92 and 23, let's say, or 22, and run the tutorial, run the cell, and again run the cell. And with this change, you will be changing the location. Well, I selected a land point. Surely this doesn't work, but you can change here the latitudes and longitudes you want to use for the analysis. You can rerun the tutorial, trying to find the regions with different results, etc. Well, this is the two main ways to modify the tutorial.
Okay. So I hope it answered the question. So a quick another question, so I can answer this one about e-learning application on the Copernicus Marine website. If you go on the use cases pages, you have a way to filter your research by keyword. So if you put machine learning or other whatever you're interested in, some example are there, so you can find something to to help you see application of machine learning. So I invite you to check the website. When using, so question from Christopher, when using data on our own environment, do we need to use or change the kernel in the Jupyter notebook, sorry. I don't think so.
Yeah, you probably will need to install a new environment, because obviously this environment, the environment we are working with, contains. I'm not going to forget again. I'm going to share my screen again. In this environment, we are using this list of libraries, of Python libraries. So if you have an environment that contains this, actually this list of libraries is not very specific. Maybe the most specific library we use is this Copernicus Marine Toolbox, but the other libraries are very common libraries in Python, like datetime, numpy, xri, matplotlib, cartopy. They are very, very common. It's easy. You will have an environment that will contain these libraries. But if you don't have this environment, or if you need to install Copernicus Marine Toolbox, this library, it's only needed to download the data. So if you want to download the data to run the cells that downloads data in your system, it's interesting to go to this button in the web of the course, the Jupyter environment. So you can get more information about how to install the the Copernicus Marine Toolbox in your computer. So you will be able to install the library you need just to download data. If you don't want to download data, if you don't need to download data just because you have already downloaded from other ways, this doesn't work. Well, if you don't need to download data, there is no need on installing Copernicus Marine Toolbox. But if you want to install that library, you can follow this button here. So you can try to install. It's really simple, actually. You just need to follow the instructions, and well, in this probably it will be installed using pip install. So
okay, thanks. Okay, really detailed answers every time. Thank you very much.
I'm sorry.
No, it's really fine. Thank you. Okay, so we have a question about if non-programmers can use our products correctly. So I will just share my screen for a few moments to show them the e-learning pages. So I think you can see my screen. So if you look there, I'm on the website of Marine Copernicus in the services, user learning services. So when you're on the main page, you go on user corner, e-learning materials, and then you have all type of tutorials for beginner, for intermediate, and you can just look at any subject you'd like, or if you want to try with RStudio or Jupyter Notebook, and you can even select the level you want. And it's a full tutorial, so you can do it yourself if you want to get familiar with language or something. So don't hesitate to have a look, even if you don't have, even if you're not a programmer yourself, don't hesitate. And so we have the question also, what would be the difference between this Jupyter Hub and the Wikio platform? And about the Wikio platform, do users just need credentials to use it? So I'm guessing the Wikio platform is working the same way as the Jupyter Hub, if I'm not mistaken.
Yeah, actually,
Yeah.
it's the same. It's the same, but well, this platform, this Jupyter Hub we provide is just a platform for training courses. You can do a lot of exercises in this platform because you can install your own tutorials. For example, the tutorials you find in the web page, you can install them in this platform and run in the platform, etc. And it's an interesting platform, but this is not a platform for work actually, because it doesn't have the needed resources to make a heavy work. Let's say Wikio is prepared to actually to do any work you need to do with Copernicus services, right? You have the access to the computational resources you will need to do any kind of study.
Yeah, and you also need credentials for Wikio. So we will have to move on to the QGIS presentation. For all of the questions I can see that haven't been answered, we will keep them on the side and we will answer them later in a post-event report. So don't worry about your question. We don't forget them. And I will let Stefania take the floor with the QGIS presentation. Thank you very much, Alvaro, and see you in a bit.
Thank you so much. See you later.
See you. Hi, Stefania. I let you begin.
Thank you, Gail. Hello, everyone, and welcome to this second presentations about the QGIS short summary about the contents proposed in this training session. My name is Stefania, and it's a pleasure to show you some information about the proposed exercises that in this case focus to complement the topics that have been proposed during this Copernicus Marine Training for Coastal Monitoring. Will focus to coral bleaching and eutrophication in coastal zones. So I'll go very briefly to give a short introduction to QGIS and the Copernicus Marine products being the core of our training, and then I'll give you some information about the implemented workflow that are proposed for using the Copernicus Marine data and perform some spatial analysis with QGIS. And at the very end, a short summary about the main findings and some essential references. Of course, before starting, I'll emphasize the fact that in the Copernicus Marine training team is providing this wonderful platform where you have all the access to all the contents, the digital contents we prepared for you. So as Alvaro already did for Jupyter Notebooks and the RStudio soon, here you will find also information about QGIS with some videos proposing an easy tutorial for installing the software and for performing some initial beginner level exercises with QGIS. And of course, if you would like to do a little bit more advanced things, you can go through the tutorial in PDF and continue by yourself and in order to explore basically what are the enormous functionalities that QGIS provides for analyzing the data. So QGIS is a free and open source geographic information system that is built up to a vibrant community, and we all can use the software, but also contribute to that. And you will find major information in the dedicated website that provides a lot of information for users, but also for developers, for people that wants to develop more advanced application based on QGIS and documentation at different levels, from the beginning to start and install QGIS up to perform some more advanced plugins with Python. Of course, here we will provide an initial overview of the basically how to use QGIS with the Copernicus Marine data. Before moving on, of course, I'll remind you that you have two ways for installing QGIS. The the traditional one, the standalone that gives you the possibility to install the executable of the last developed version or the long-term release. Here in this training, we use the long-term release being of course, the stable one and also the reference version we used for proposing the exercises. But if you want to exploit the possibility also to install different version of QGIS in your laptop and exploring the difference between for instance, the long-term release and the last developed version that might have new functionalities for your interest, I advise you to go through the advanced installation through OSGeo4W. The objective of this training basically has been to somehow increase the user uptake and awareness on coastal environment, particularly on the possibility to use Copernicus marine data for performing some geospatial analysis and trying to find the proper way for supporting the monitoring at coastal scale for two specific, let's say, issues that are stressing our coast, the coral bleaching, and we will give some examples in the African coastal area of Kenya and Tanzania, and eutrophication with a focus on the Western Mediterranean Sea with a zoom in the Ebro Delta. So where, I mean, just to provide an example on how particularly the interface between the sea and the coast through the rivers are particularly stressed by this kind of events. Of course, QGIS is supported by the Copernicus Marine community through a very helpful plugin that is the one proposed also in the platform that we suggest you to download, and there is also the documentation for the step-by-step configuration in your QGIS environment. And here, basically, I try to summarize the main steps. So try to follow the numbers to, let's say, progressively learn how to load NetCDF files in QGIS. So you have a window that provides basically the map of the NetCDF metadata in your in a graphical user interface. So through the board that you see here, you can visualize the data, the NetCDF data and the path where the data are. You can add the specific essential ocean variables as of your interest as a layer, and this will automatically open the second window where you can select basically the information contained inside the NetCDF files, like in this example, the time or the depth, assign them into a specific group that then is displayed automatically in the layer board of your QGIS. And so after that, you will be able to visualize your NetCDF files. The Copernicus Marine NetCDF plugin works not only for scalar fields like temperature, salinity, significant wave height, and so on, but also for vectorial fields like currents. And all these are nicely explained also in the tutorial for this plugin. In the specific exercises that we propose, we tried to give you somehow an overview on how to visualize this the data, the Copernicus Marine data, coming from the model products, but also from satellite high-resolution product provided by the service. So the first exercise will mainly use the model data from the global ocean analysis and forecasting system for the physics and for the biogeochemical component, working mainly with temperature and phosphate over a reference forecast cycle. So taking basically the any production provided daily by the Copernicus Marine Service through the global ocean forecasting system. And the second exercise will provide you information about the regional model product, particularly how we can use the Mediterranean and the Atlantic, Iberian, Biscay, Irish physical forecasting systems in the area of the Ebro Delta, and for providing an added value in this in the main objective of monitoring eutrophication in coastal zone. We recommend also to use the high-resolution product, satellite product for the Mediterranean Sea, L4 data. as shown here in this short card, for the chlorophyll particularly. So in this case, in the second exercise, we will focus on salinity provided by the models and chlorophyll data provided by the satellite observations. So let's start very briefly on coral bleaching event. You know, this is a particular, let's say, stressful event induced by climate change, especially in affecting the coastal regions in the tropical area and subtropical area. And this is due because basically the corals under stress because of the increase of the temperature in the ocean and the acidification basically lost the zooxanthellae, that is the symbiotic algae that living in the corals. So because of this, progressively the corals start to lose their colors and so becomes white. Basically, this is a extremely severe event that indicates also how the climate change is affecting dramatically the coastal region. And as I was mentioning to you, and there are references, huge literature about that, this is due because of anthropogenic global warming, pollution, ocean acidification. And there are works in literature that try to, let's say, provide the indication on how to monitor this kind of event just by analyzing the essential ocean variables provided by systems, by forecasting systems, and by observations. In our case, we will focus on model data, as I was mentioning to you before, from the Global Ocean Forecasting System, and we will try to use QGIS for producing maps that fits with these ranges that are particularly for temperature and phosphate critical for the possibility of corals to get induced by this event. So the region of our interest is represented in this slide. So we are referring to the Kenyan-Tanzanian coastal region that is particularly active from the circulation point of view. So we have the Northeast Madagascar current and the East African coastal current that is flowing along the coast. And what are basically the steps that we followed basically in the tutorial and also in the documents that has been provided to you. We started with a basic, let's say, application that concerned the visualization of the essential ocean variable maps for the global product. So with the Copernicus NetCDF plugin, you can load basically these NetCDF and visualize them in your QGIS board and applying some customization in the color map in order to fit well with the characteristics of the variable that you are representing. Then QGIS is extremely powerful when we want to extract information in some specific area. And for instance, in this slide, in the second point, we selected the coastal area where we want to concentrate our monitoring activities by simply drawing a polygon. Of course, you can refine the polygon on the basis of your needs. For instance, taking the bathymetry as a reference, or by considering particular some where available in other coastal regions, some specific infrastructure in order to, let's say, improve the way you want to monitor this kind of events or even others events that can occur in coastal area. Of course, we choose this area because it's extremely valuable with its rich of corals, and so is an ecosystem that we want to preserve. And we want to use the Copernicus marine data for supporting this kind of monitoring. So you have the step-by-step instructions on how to draw the section, and then how to extract the physical information provided by the Copernicus data for temperature and for phosphate by clipping the rasters that you have uploaded from the NetCDF into your mask created by your drawing. And after that, you have in gray now the region where the Copernicus marine data are available, so you can basically focus your attention only in this region and further customize the map in order to be able to draw it in a proper way in a bulletin. And at the end, based on the work that I was showing to you before, you can use QGIS for reclassifying the values provided by your raster according to the thresholds that have been proposed for the global ocean in this work. But of course, this analysis, particularly in this region, can be further improved by the experts in the area because they know much better what are the level of the thresholds, the ranges that can be not tolerated by the corals and can then lead to specific coral bleaching events. So this is just an example and proposed for a forecasting cycle, because in this way the coastal expert can use QGIS basically to monitor in forecast mode how the temperature and phosphate are, let's say, characterizing the region, and when to set alarms for potential coral bleaching events. The second physical, let's say, event that we are proposing, that we are describing here in this training session is related on eutrophication. The eutrophication is basically an event that is induced by increased concentration of nitrogen and phosphorus in coastal waters that are particularly rich of these elements because of the rivers outflow in the coastal water. So of course, again, the eutrophication is particularly severe event that can reduce the biodiversity in coastal region, and there are also in this case many works in the global coastal ocean that talks about this event, particularly how to characterize it, and there are findings like in the map that is shown here of combined effects of eutrophication and deoxygenation in the global coastal ocean. So these are basically events that deserve a dedicated monitoring again. And in this case, just as showcase, we propose the Ebro Delta because it's a river, because it gives us, of course, the opportunity to introduce the regional products available in the Copernicus catalog, but also the high-resolution satellite products provided by the Ocean Color Thematic Assembly Center in the Copernicus Marine Service. And the Ebro Delta is an example, for instance, of a natural protected area that we want to preserve from these, let's say, and monitor, but particularly in case of this kind of events, being the region supplied by nutrients rich in nitrogen and phosphorus due to the intensive agriculture activities that are particularly interesting the region. And here, of course, there is it will be for more scientific studies also important how to link all these events also with the circulation that is occurring in the region. And the regional models are providing high resolution at regional scale, of course, representation of these dynamics. In QGIS, how we use this example for giving indication on how to monitor these kind of events. Basically, the first part of the tutorial was focused on visualizing the chlorophyll monthly maps in the region. Here you see the Ebro Delta, and you see also the powerful capacity of the satellite product in covering a very, very high resolution region in the regions in this particular domain. So you have the two bays that are fully covered by the satellite product. And for instance, any coastal planner or expert might be interested to monitor some specific points inside the base, as the reds that are provided in this short example. After that, how we use QGIS for, let's say, getting the data in these points, basically by interpolating the chlorophyll data at station locations using the sample raster values function. That is one of the very huge list of functions provided by the toolbox of QGIS. And this can be done automatically. If you have many files, the system allows you to run it in batch processing. So in one shoot, you can launch many files to process. And output basically the corresponding value, where available, of course, of the satellite product in the points of your interest. In this case, you have them in tabular format that then you can export and further analyze through, for instance, Jupyter notebooks or other languages for performing more advanced statistical analysis. And with the raster calculator in particular, the exercise was showing how to compute a seasonal map of chlorophyll and then extract the seasonal values of chlorophyll in this specific region, in these specific points. And through the reclassification function that is very straightforward in QGIS, you can modify your map in order to classify per ranges and have a more effective outlook on the map on the regions where you have the highest concentration of chlorophyll. The last example that is proposed is instead showing how to use QGIS for intercompare, in this case, the two model products provided by the Mediterranean and the EB physical forecasting systems provided by the Copernicus Marine product catalog. And here with you can have, with the visualization, an outlook on the differences between the two models in terms of resolution, but through the profile tool, you can also interactively define a section where you want to extract the salinity values, particularly in your target region. And this is an example on how it works. It's very interactive. So you have in green the EB solution, and in blue the Mediterranean solution, and in front of the river mouth you can appreciate and take your evaluation on the differences in salinity between the two models. And of course, as suggested also in the documents, in the digital contents of this training, you can further explore the physical meaning of or the setup of the two models by accessing the quality information documents provided by these two forecasting systems in the Copernicus Marine Product Catalog. So, as general, let's say, summary of this tour, fast tour on the contents of the QGIS exercises. Of course, with QGIS, you have a lot of capacity for analyzing with geospatial tools the Copernicus Marine products in a very extensive way. We have learned how to use some basic functions for executing automatically numerical algorithms for extracting values on a specific region, performing some numerical analysis, for instance, computing the mean of the chlorophyll in a certain period, like shown before with the raster calculator, or sampling and interpolating raster values on specific points, but also regions. And of course, in terms of visualization, you have the possibility to reclassify the raster values according to your for your specific needs. In the case of monitoring, for instance, by applying these ranges that can be straightforward for a stakeholder for or decision maker to further process the information for specific needs. And of course, everything is, let's say, enriched by the powerful plugins that we can use to have been proposed, like the Copernicus Marine NetCDF plugin and the profile tool. But there are, of course, many others, and they, depending on your needs, you can explore them through the tutorial that show you how to do that. So here are some very short references also available in the PDF. And with this, I thank you for your attention.
Thank you very much, Stefania, for the nice presentation. We have plenty of questions for you.
Okay.
So I pinned this one, and we have the second one a little bit in the same idea. Someone is asking about the use of WFS and WMTS services instead of the plugin to get data. I think it's connected to QGIS. I don't know about that. I don't know if you know that.
Well, I know that there are, of course, QGIS provides some tools for accessing the data through GeoServer. So if you have a the address of your geoserver, you can configure the possibility, I mean, to access the data through that. Of course, WMS, I think, is the service is also supported by the Copernicus Marine Service. Maybe this can be something alternative, let's say, way of accessing the data can be something useful to detail maybe afterwards as an appendix, for instance, to our technical document. But
Okay.
also, let's say in these kind of tutorials, being a first way of accessing the data and use them in the QGIS environment, we are exploiting the way of accessing them as explained very well by the Copernicus Marine training team yesterday during the first day. But of course, QGIS offers many capacity also for using the geoservers. That's
Yeah. Okay. Okay. So thanks. Okay. We have this one about making available Copernicus Marine QGIS plugin for Linux OS. So I think it's already available for Linux, if I'm not mistaken.
You are right.
Yeah.
You are right, Gail. Of course, QGIS is a multi-operating system software. So, of course, the exercise is done proposed in Windows, but through the installation notes, you can have, and also, of course, through the website, you can learn how to install also QGIS on your Linux operating system and perform exactly as proposed in this training the exercises in Linux. It's not going to change the approach.
Yeah. Okay. Okay, thanks. So, if you have rated, I think maybe you do this in your full tutorial, I guess, add and insert data to QGIS. Yeah. So I invite the
Yes.
person who asked the question to look at the full tutorial on YouTube. You will see how to do it.
Exactly. Yeah. It's done and described also in the technical document. So
Yeah.
I mean,
Yeah.
no problem for that. It's you go there and you find the answer. It's also a way for stimulating you to watch the video.
Yeah. So go on YouTube and download the PDF.
Yeah, exactly.
So this question is about using RStudio, about QGIS to do this. So yeah, we can definitely use RStudio to do that. We have another tutorial with RStudio afterwards, so you will see it's definitely possible. So, question from Fatima: can this framework be applied to other regions, and is it possible to conduct comparative data analysis across different areas?
Absolutely, yes. That's, I mean, the scope of these trainings is also to show you the amount of tools with which you can perform this kind of analysis. Of course, as you guys were saying before, there are also some other training sessions that were focused on other regions and giving complementary information. So, but definitely we choose the areas just for, let's say, demonstrating the capacity, but absolutely you can recolocate all these kind of analysis and approaches in other regions. Absolutely. This is at the end the scope.
So about this question, Annick, so yes, the marine data is validated everywhere in all regions. We upgrade our products. We ask the users if they're happy with it. So it's well enough if you want to use our product in this type of region. We don't have really small resolution, but you can still use them. Don't worry, it's really fine. Okay. Can QGIS be used to monitor wave intensity as well?
Of course, I mean, the wave product can be exactly, I mean, of course, depending on the type of application that you would like to implement, you can still use QGIS with the same and even more capacity for performing this kind of analysis. The final message, I mean, regarding QGIS is very powerful for performing geospatial analysis and automatize them also with in context of more complex applications. And indeed, as you have seen for physical variables and biogeochemical variables in this tutorial, the same type of analysis can be performed also with wave product and target your functions for monitoring specific events or specific processes.
Okay. Okay, that's nice. Nice to know.
Yeah.
I guess the answer would be yes. Can you reclassify a layer by choosing only values in certain lists? Well, obviously you can download our project and choosing the depths, but I guess you can also do it on QGIS if you didn't do it at first. You didn't do it
Yes,
at first.
if you download, for instance, the global product, the NetCDF, and you have the prescribed layers provided by the model, where the model is resolving the Navier-Stokes equation, then and you load them through a plugin, for instance, the Copernicus plugin, then you can let's say the raster calculator can work also on as soon as you prescribe the coordinates of where you want to that you want to use for performing the calculation. Of course, you can also do it in the vertical direction, let's say. So
yeah. So it's almost the same answer for Luna, who's asking about longitude and latitude. You can do it downloading the data, and you can do it after downloading the data in the same way. So yeah. So this one I don't know. Perhaps you know, Stefania. Can we visualize the file on Google? I don't think so.
To tell you the truth, I didn't explore because I mean, at the end with QGIS, eventually you can integrate Google Earth base map.
Yeah.
With the NetCDF as I was showing in the as I show in the training, but
Yeah.
I
Directly like that, I don't
the
know.
truth, I'm not
Yeah,
let's
I
say
don't know.
using Google Earth in this kind of situations. I prefer much more to use QGIS and eventually
Yeah.
other tools like Jupyter Notebook shown by Alvaro.
Is it possible to create histograms analysis on QGIS? Can you do that directly, or do you have to use another script?
This is, let's say, tricky because in the sense that you have some tools for automatically plot based on some Python. So there are plugins, and maybe we can. There was also another training showing particularly this. Of course, then it depends on the capacity you would like to in the sense the specific function that you want to show or type of output that you want to produce. Usually these kind of things can be externalized by doing them in Python and make the connection between QGIS and Python, for instance, through the Python embedded capacity of QGIS for doing that. But surely there are some plugins, interesting ones, that can provide you, as the profile tool I was showing you, the possibility to plot surely time series, also scatter plots. I never tried with histograms, but maybe this can be a good thing to for us for the next trainings, eventually to investigate also this kind of output. You are interested.
Okay, thank you very much. We will just take these last two questions, which are a little bit the same concerning non-values and gaps in the data, if we can fill it with QGIS and if it accepts it. I don't know if you know. I guess we can do with interpolation, or maybe there are other techniques, I don't know.
Well, this, I mean, the Siemens data being in CF climate format, let's say in a standard format, should recognize the field value automatically, in the sense any kind of tool that is going to import the netCDF is able to understand that that one is a field value that must be, let's say, that when the user can automatically decide what can be the next level of filling for substituting, for instance, none with other values. So up to now, my experience is, of course, with the Copernicus marine data in this sense is quite straightforward. So in case you have specific cases where QGIS is failing or is not, as you are writing, not accepting non-numbers, please let us know, because this can be also something to discuss with the producer in case this standard is not working. Because as far as, I mean, from my experience, this can be is quite straightforward in QGIS. But please, if you have information on which is the product that is giving to you this kind of issue, we can try to understand better and support you.
Okay, thank you very much. For all the questions that haven't been answered, don't worry, we'll do them in a post-event report, but there are still plenty of questions, so we don't have time for all of them, unfortunately. I will leave the floor to Alvaro to present RStudio tutorial, and thanks again, Stefania, for the nice presentation.
Thank you, Thank you.
Hi again. Welcome to anyone to this tutorial presented for RStudio and our programming language. Well, let me share my screen. This tutorial is quite similar to the tutorial, the Python tutorial. Actually, this tutorial is the translation of the same tutorial in Python to RStudio and our programming language. So in this tutorial, we are presenting again the same study of storm surges associated with cyclones in the Bay of Bengal. And we are going to do the same analysis done before. We are going to use two different products, Copernicus products, etc. So to access the tutorial, as we said before, there is a tab up here in the web page of the course. So you can click in this tab and you will get into the web, into the page of the R contents. Here in this page, you will get information about how to install RStudio. This is because a difference of this tutorial compared with the Python contents. In this case, we are not providing a Jupyter Hub system to run the tutorial, so you will need to download the contents and run the contents in your own computer. So to run this content, you will need to install RStudio, and here we give you some information and a short tutorial on how to install RStudio. It's quite straightforward. You just need to download two installers and run the installers, etc. There shouldn't have many difficulties for installing the IDE. And after that, you can download the tutorial and run the tutorial. To do that, you have this button. So you will be redirected to the Mercator facilities where you can download the contents of the tutorial. That contains, as you will see, there is a folder with the data you will need for the tutorial. Also, you will get a MP4 file that is the video tutorial presented and included in the web page of the course, and you will get two different files, which are the PDF files with the documentation and the R script. Regarding the PDF file with the documentation, yes, you will see that it contains all the information of the tutorial with the sections we go on during this tutorial, an introduction. We explain the data sets in the tutorial, and we go over three different sections, which are the tutorial setup, the plotting maximum sea surface height maps during cyclone events and make a comparative analysis of sea surface height time series from 2 different Copernicus products. Here I give you some information, introductory information that gives some information about the storm surges and the cyclones in the Bay of Bengal. And after that, I give you information about the 2 data sets we are using in this tutorial. For this tutorial, we are using data sets provided by satellite data. As you can see here, we are using this product, AL4 and reprocessed, and we are using data from 2010 to up to 2019. And here, well, there is a window we are using, and we are using the same window also for a different Copernicus service product that is a product generated by numerical modeling. It's a reanalysis product. Like this one is actually, it's the global ocean physical reanalysis. And we use actually the same variable and the same geographical window and the same temporal coverage, right? Well, coming back to the presentation here. Well, here we have also in this folder, you will have also the R script. And once you have installed the RStudio IDE development environment, you can access the script by clicking on the script. And you will get something like this. Here you can see the environment that is provided by RStudio. Here there is 4 different working space or 4 different panels. In RStudio you will find this upper left panel that contains the script that we are proposing for this tutorial, and you will go over this script and run the script in the console that you can see here. The console is just a command line for R, so you can type any R command, like, for example, you can create a variable called 8 equals 4, and well, you can use this variable 8 plus 4 equals 8. And well, you can run the lines of this tutorial by pushing in your keyboard, selecting the lines and pushing in your keyboard Control Enter, and you will run in the console these lines from the script, right? So you can follow the tutorial by pushing Control Enter, and you can include here in the script any changes you want to include, just in case you want to explore a little bit how the code works and if you want to include changes. And also you will find in the bottom row, you will find 2 different panels. Here, a panel with a list of variables you are creating in your session, and also a panel that shows the plots you are creating in your session, right? As I said before, in the documentation, there is, for example, here, you can see in the documentation, there is 3 sections that are called plotting maximum sea surface height maps during cyclone events and comparative analysis of sea surface height and series. These sections and the tutorial setup are connected with the 3 sections included in this R script. So this R script contains the same sections. They are specified in the documentation, and in the documentation, going directly to the sections, for example, tutorial setup, you will find the code we are proposing for the R script. So we explain any code with any line we are including in the tutorial, and you can navigate through different functions we are using, and we explain the use of the different functions we are including in the tutorial, and we explain everything about the tutorial, what cyclones are we analyzing, etc. So you can go over these three sections: the tutorial setup, the plotting maximum sea surface high maps during cyclone events, and the third one, which is the comparative analysis of sea surface high time series for these two Copernicus products. Here we are doing an analysis, as I said before, of the storm surges associated to cyclones in the Bay of Bengal. And here we are showing some results of these two Copernicus products. As I said before, we are working with a satellite product and also another product produced by numerical modeling. So we are analyzing this cyclone by using these two products. As in the case of the tutorial, the Python tutorial, we are proposing the three different cyclones for the period of we are analyzing, 2010 up to 2019. For example, we have here the option of work with the cyclone Giri, the cyclone Had, and the cyclone Fani. In the previous case, I worked with Giri, but in this case, in the video tutorial, I propose to work with Hudhud. So we can change the cyclone you want to analyze in these lines of code. And here we are producing different results, as I said before. First of all, we create a quick look of what happened in the cyclone we are analyzing. For example, in this case, the first result we create is the plots of the maps of maximum sea surface high from satellite and reanalysis data. In this case, or as you can see, I've worked with Hudhud cyclone. So here we can see the differences between both products. As I said before, the spatial patterns produced by both products are quite similar, but as you can see, there is a difference. As before in the case of Python, there is a difference in the absolute values produced by both products. And also there is, you can see pretty clear here the differences of resolution of both products. As you can see here, in the case of satellite data, you can see clearly the pixels of the product, while in the case of reanalysis, the pixels are much smaller. So you can see there are a clear difference in the resolution between both products. And since we see some differences between these two products, we go doing the same analysis than in the previous case. So we select, first of all, oops, I'm sorry. We select a specific geographical point, like this one. In this case, we have proposed this, but in the tutorial, you can change this geographical point, the specific section here. We propose these three locations, but you can change any location here. So we propose a specific geographical point, and we compute or we create the plot of the time series of both products, including the full time record. And also we include this thin line that shows where the cyclone we are analyzing occurred. So we can check that actually there is a clear bias between both products, and maybe there is some differences not only in the bias, but also in the variability of both products, like here, for example, on here. Well, since we find these two differences, we go to a deeper analysis by plotting a scatter plot of both products. In this scatter plot, I'm gonna do this higher, bigger, and bigger. In this scatter plot, we see, well, this takes a few seconds to in this scatter plot, we can take some conclusions. For example, we can see that despite of both products provide very similar results in low values of sea surface high, the spread of the points in the higher values in the upper half of the plot is higher. So the differences between both products in this case, in this specific geographical point, is higher. But despite of that, since we are plotting the regression line between both products, we realize that the slope of this regression line is 1. So both products in average produce very similar results with very similar variability, but they have a difference of a bias of 0.4 meters. And here we are also showing in orange dots, the dots corresponding to the cyclone we are analyzing, and we realize that this cyclone actually provides, these two products provides different estimations for this cyclone. Well, as you can see, the dots corresponding to the cyclone goes quite far from the red line that corresponds to the line of the regression line. And well, we discuss a little bit these differences, and these differences actually correspond to a bias, mainly to a bias that we should remove by calibrating these products. It's a classic result we can see in this kind of products of sea level. And well, these are the results we are showing in this tutorial and discussing in this tutorial. In the tutorial, you will see we can explain a little bit the conclusions of these plots, and this is a very short summary of the contents of this tutorial.
Thank you very much, Alvaro, for your nice presentation. For your second nice presentation.
Thank you.
we have some question for you, as you might have guessed.
Yeah, I saw a question before in the session of Stefania about R. Maybe.
Yes. So the first one, actually, we have more or less this question twice, is about downloading layers on the website because the data files are too big, and they want to know if it's possible to use R to overcome this problem. So I guess you have already made a tutorial to download data with RStudio, but well, I let you explain.
Well, the thing is, that's true. The website has a limit, I think, to 1 gigabyte of data you can download. So I would recommend to install the Copernicus Marine toolbox in your system. There is some information in the Copernicus help webpage about how to use Copernicus Marine toolbox with R. We haven't used it in this case, but in future tutorials we will surely include that information.
Okay, thanks. So, do you know if there is a script utility available in R that would subset from an NetCDF file? Well, I guess so.
Yeah, actually, well, maybe I don't know if there is. I don't know if this user wants to create a new NetCDF file, but I think it's quite simple to subset a specific region for your data. I explain in this tutorial. You can find some exercises to explain how to subset not only specific regions, but also specific points. So you can use, I think, that information to create a subset. And after that, if you want to create a new NetCDF file storing this data, you can use the classic functions of.
Yeah.
There is not an utility, but for sure you will find
Yeah.
many different functions that you can use to do that.
Yeah, I think you can use NCO, or I think it's named CDO on Linux in a command line, just one line to create a subset with an etcdf file, I think.
Yeah, there is also other options, for example, CDO or other tools that works actually really fast, and
it's really fast and really simple.
Yeah.
Great invention.
Yeah.
Okay. So there is a question about how to use the equation. So do we need to use both satellite data and reanalysis data always for a similar analysis? So perhaps you answer this in your full tutorial.
Well, I will recommend that if you want to use this kind of product in a real case, first of thing you should try to have a look how these products fits in your specific case, in your region, and for the kind of events you want to analyze, etc., etc. And for sure, probably you will need to perform a study of the calibration of both products, but because maybe in the case of scissor face high, the reference level sometimes is a little bit different, and that produces strong differences between both products or between products. But these differences, despite of both products, has very high correlation. So the variability of the scissor face high is captured in the same way, but the reference level is not exactly the same. So for a real case, I would recommend to make a calibration of both products and evaluate what product is more interesting for you. And also, there is always the option of work with an ensemble of products, making the mean between products and analyzing, so you can analyze the variability or the uncertainties of your estimations.
Okay, thanks. And concerning the precedent question, I just saw that Stefania answered that the Copernicus Marine Toolbox can in fact provide the capacity of subsetting for the users if you want to try it at home. So, okay. We have also kind of the same question there. So the browse there about the difference between the satellite data and the reanalysis data. So one is asking if you can do a live demonstration of the difference in the plot, and one is just asking why there is a constant difference. So obviously because it's not the same data, but if you want to explain a little better.
Well, I can try to do it, but I don't know. I don't know if this is going to work fine in the first try. So if you want, I can try to share my screen and go to that studio.
You're not sharing the screen actually for now. Yeah, thanks.
No, yes. Well, in this tutorial we have here in the second section, the TDF here, well, as you can see here, we compute the temporal average of all selected products, the satellite and the reanalysis. So maybe we could try to type something like difference equals to sat.max minus rea.max. So we can, since we want to compute a percentage, we could try to divide this by rea.max, and we can multiply this by 100. And probably see how this works. Probably if we run this line, well, this is maybe it's too straightforward. I should have to have a look how to compute it, but probably the solution will be similar to this one. Looking to the arrays we are creating for maximum values in satellite and reanalysis, and after that you just have to compute the differences and compute a percentage, and you will insert this in a new variable that after that you will have to use to plot the map, right? So
Okay.
once you okay.
Okay. Okay. You can try this at home then.
Yeah, maybe in live session directly in the code, maybe it's too direct. Sorry, but for sure the solution is something like that. It should be something like that.
Okay. So another question: when working with big satellite datasets, to see which values in each of these vectors air recognizes as missing, what is a common code to use?
Well, yes, there is a code to use when you get information from NetCDF files. You can use a specific parameter to define that the system should recognize the NaN values. But actually, in the functions we are using in this tutorial, that is var.getVar.nc, automatically is the NaN values are recognized. So actually, there is no need of doing anything special. You just need to follow the tutorial, and the NaN values will be recognized.
Okay. Okay. Thanks. Okay. One of the last question. So about reclassifying in a dataset, can we download the reclassified version of the dataset to GeoTIFF version or raster file? So I don't know. I will let you answer this.
Yeah. Well, yes. In this specific tutorial, I am not downloading data as raster because, well, since I wanted to run the tutorial making some computations, I found more efficient to download directly data as arrays and work with data as arrays. But there is tutorials that we have presented where we read data as raster file. That is, for example, for plotting maps. If you just want to get the data and plot maps, it's raster files, raster objects are very convenient. So sometimes I use it. I would recommend to explore the other R tutorials. There are in the web page. So for sure you will find some tutorials that use raster files.
Yeah, I think so too. There are plenty of tutorials, so I'm sure you can find what you're looking for.
Yeah.
So the last question, it's more the general question about the Copernicus Marine Toolbox for MATLAB. So unfortunately, it's only for Jupyter Notebook right now, but I know they're thinking of doing it for more than Jupyter Notebook, so we will keep you available. I don't know if you want to add something else, Alvaro.
Yeah, I think, currently the Copernicus Marine Toolbox is available directly in Python, but you can also install the Copernicus Marine Toolbox in your system. So you can run this toolbox directly in your system by using command line.
Okay.
So at the end, there is no need of any specific program language to use it, because you can use it like you work with any other libraries by typing some commands in the command line of your Windows system or etc. So since that, you can use your MATLAB or any other programming language to give instructions directly to the system.
Okay, good to know. And also, now we are at the last question. So about the SAR data. So I guess you can use R to analyze SAR data because you can do it to LRM. I guess it works the same way. It's the same file. So yeah, definitely.
Yeah. Actually, it's the same. Actually, it's a good idea for future tutorials in future courses.
Yeah.
Maybe we can try to use that kind of product to give
the file might be a little bit heavier than LRM1, but yeah, it works the same.
yeah, it's the same actually.
Okay, great. Well, that's all for the question. So thank you very much, Alvaro.
Thank you.
Thanks again to Stefania, to both of you. It was really interesting. I hope everyone enjoyed your tutorials. So for everyone, I hope you could learn a little bit more about what Copernicus Marine Service offers in terms of data and information. And we hope you have learned something with some of the direct application we showed yesterday for those of you who are there and today. A little thing on the Jupyter Notebook tutorial. So I have the user support told me that normally it should work on your local space on your computer and also on your own personal space on the Jupyter Hub. You just need to be very careful to copy paste the directory on your own personal Jupyter Hub space. It should work, but we have some update on the Jupyter Hub, so locally it will work and normally also on your own space, but just be careful where you put it on the hub, and it should work fine. The user support just confirmed it, so don't worry about that. If you have some question, you can send them an email, don't worry. And lastly, so about the survey, which will go back up to the screen, thank you. I just want to ask you to take a few minutes of your time to fill in the survey we made for this workshop. So it would be wonderful if we could know what you think about this and what you thought of today's session. And it can be very useful for us to improve. We already have some new idea with your question for the next training. So thank you very much for that. Before we go, all the replays and presentations will be available in the next 10 days. We will send you an email when it's the case. And today you will also receive an email with a certificate of participation to the event for everyone who were there today and yesterday. And well, thanks again for your presence, and I hope you had a nice time, and perhaps seeing you at the next training. So have a good day and goodbye, everyone.